Hello everyone. Today we will see how to calculate eigenvalue and eigenvector. So we will find out from a matrix eigenvalue and eigenvector. For that, consider a square matrix. To find out eigenvalue and eigenvector, the matrix definitely have to be a square matrix, say 4, 4, 2, 1, 3. So our eigen equation, so this is our given matrix. So first step is eigen equation. Suppose a matrix called A will definitely have an eigenvector. This is eigenvector if it's satisfied lambda x, which is here, this lambda is eigenvalue, and already mentioned that this is eigenvector. So if any equation satisfy this one, then it will be known as then definitely this one will be eigenvector and this lambda will be an eigenvalue. It's an scalar value. Okay. So we will from this equation, what we can write, we can take it to the left side. Ax minus lambda x is equal to 0. Next, what we can write it, ax minus lambda, we will add an identity matrix I, and this will be our x as it is 0. For note, here lambda x is definitely equal to lambda I x. So that's how we can write this one. Next, what we can write, we can take common this x. So then it will be remain with a minus lambda I x is equal to 0. Now, if you solve this equation, what you will find? You will find a minus lambda I is equal to 0 and x is equal to 0. Here, if you notice that this is our eigenvector, and this eigenvector is all about, here we are dealing, and it gives us a 0 vector. That means no direction, no magnitude. So what will I do with this kind of a matrix? In mathematical term, it's known as trivial. Trivial means not important. Why not important? See, there is no direction, no magnitude. So what is the value of this matrix? So making that important, we have to make sure this x such that x never equal to 0. To satisfy this one, we have to make this part not invertible. Now, what is not invertible means that so this invertible means that this invertible means that it should be singular. When a matrix is singular, if its determinant, say for a matrix, here for this matrix I wanted to make a singular, then the determinant of a lambda I will definitely have to 0. If the determinant of some matrix is equal to 0, then it will be known as singular. And what is this singular means? It's not invertible. And that is how we will have a solution for this x, which will be not equal to 0. Let me remind you what is invertible means. In simple term, think about is like a door, your home door. This door, one thing you can do, open, and you can close it. Not invertible. Invertible means something you can have an action and you can undo that action as well, like a door. But not invertible means that the door will close all the time. You cannot open that. So something, any kind of a matrix, if you can take it to its back shape, it will termed as an invertible. But when you cannot do that, it will be not invertible. If this term is not invertible, then this will not equal to 0. That is the reason why I'm doing this. So our next task is, yes, we have to find out this determinant of a minus lambda I is equal to 0. So we will do our job here. Determinant of a matrix is basically 4, 2, and 4, 2, 1, 3 minus this lambda, and this identity will be like say here lambda, and identity matrix 1, 0, 0, 1, okay, 0. So we have to find out the determinant of this whole thing. That now, if you can write it like this, 4, 2, 1, 3, and you can write it like this one, lambda 0, 0, lambda. Okay, now that when you minus that, you will find 4 minus lambda, and 2, 1, and 3 minus lambda is equal to 0. So now we will ready to find our determinant. We will multiply each other and minus them. So we will have 4 minus lambda into 3 minus lambda minus 2 is equal to 0. Now from this solution, you will find lambda square minus 7 lambda plus 10 is equal to 0. Now if you solve this equation, you will find lambda minus 5, lambda minus 2 is equal to 0, and if you solve this, lambda is equal to 5 and lambda is equal to 2. So we found two lambda's values, termed it as a, say, lambda 1 is equal to 5, lambda 2 as equal to 2. Okay, we're ready to find, we already find our eigenvalue. So these are eigenvalues. This is our first one, this is our second one. From each eigenvalue, now we will find the eigenvector. For first of all, when lambda is equal to 5, we will solve a minus 5i x is equal to 0. Okay, we have a matrix called 4 minus 5, 1, 2, 3 minus 5. this x will have two identity, and as it is a map vector, so we will write it as a 0. And if you solve this one, you will find -1, 2, 1, -2, x1, x2 is equal to 0. Now if you solve this one, you will find minus x1 plus 2x2 is equal to 0. Then x1 is equal to 2x2. So for eigenvector vector x1 is equal to 2 and 1. Why? Because x1 is the twice of x2. So this is x2, then x1 will be twice of this x1. So that is how we write this. Okay, this is first eigenvector. Okay. Okay, cool. So we first our eigenvector, we found that. Now we, for lambda is equal to 2, we will find the we will solve again a minus 2i x is equal to 0. Okay, so we will find 4 minus 2, 2, 1, 3 minus 2. You will find, you can write x1, x2 is equal to 0. So if you solve this one, you will find 2, 2, 1, 1, and x1, x2, you can write it as 0. Now from here, if you multiply 2x1 plus 2x2 is equal to 0, then definitely x1 is equal to minus x2. So now it's our second eigenvector will be, say, second. It will be, say, this will be x2, this will be x1. x2 is -1. Sorry, x2 is 1. Then x will be -1. So we found our two eigenvectors. So it's our second eigenvector. This is our first eigenvector. So we have eigenvalue 5 and 2. So we've found the eigenvalues and we now found the eigenvectors. So that is it, how you will find the eigenvalue and eigenvector from a square matrix. Thank you very much.